Good afternoon and welcome to this session. This is Mr. Mutunga, Lab Technologist Physics. This information is intended to reach the first years of physics who are doing experimental physics, which is Physics 121. It's a guide for it to help you to complete your report writing. If you can check very well, it's intended to Chuka University Department of Physical Sciences, Physics section. The practical manual, if you can remember, you had that practical manual sometimes back for the first year, first semester. But this information within this instruction manual, it will aid towards writing at least a good report for your first semester and even to all through to even for the and fifth year maybe. I'm an instructor, Stanislas Mutunga. You can check if you have any problem with any whatever is happening here. You can reach me through that number. I'll give you further assistance if you wish to. This is meant to these groups, the EB2, the EB6, EB7, and maybe there is EB8, EB16, EB17, EB24, and EB5, which are the education which who are doing physics combination with any other subject like chemistry or maths. The purpose of this handout is to introduce young researchers to writing good laboratory reports. In other words, it gives a brief description of how to communicate the results which you did in the laboratory, the results you got in your laboratory or the findings of an experiment you did. Remember very well, physics experiments, they come as a unit. And you are required first to write a report or to communicate your findings to the instructor, which should follow the format which we will discuss somewhere down here. If you can check very well, a laboratory report should be given in the following format. Now let's take an example. Now you are having your report book, maybe the one you've constructed using your foolscapes and some graph papers binded together using a spiral format. The first thing, let's say, for example, you are dealing with a report like M1 determination of, no, not M1. Let's talk of a report like determination of G using a simple pendulum. And now you have the data, you have your rough copy somewhere. But now you want to compile the final document, the one which you'll submit for marking to the instructor or to the person who will be in able to mark that one. First thing in the first page, before you're doing any other thing, you're supposed to record the date when the practical was done. But remember very well, that is on the top page, wherever you want, either to the right or the center or to the left, it's upon you. That is the date when that practical or that experiment was performed. But after that, now you can remember now that after that you have the title, which should be included in the first page. The topmost now, immediately after the date, the one which you did or you performed that experiment. Now after the title, remember sometimes most of the time you are given the title, but you have the freedom to manipulate that title to be more appealing, but not outside the scope of the experiment. Now, after the title, you have the title now. Remember very well, you have the title. So after having the title, that's where now the real work emanates. But remember very well now, after the title, you're supposed to be having the aim or the objective, and this should convey the reason for carrying out the experimental test. In all physics practicals are designed with specific objectives that must be achieved under normal circumstances. And you thought that any student or a student should state the aim of the experiment to inform of a statement at the beginning of the report, just after the title. Like for example, let's check now, we had a title of determination of a resistance of a given wire using meter bridge. That was the title like that. Now, within this experiment, you are required to determine the resistance of that wire and the specific resistance of its material. Now, let's say now you are presenting that objective. You're supposed to write something like to find the resistance of a given wire. Like, for example, if you're given a nichrome wire or the chromium wire, to find the resistance of a chromium wire using a meter bridge and hence determine its specific resistance. Or else, if you are dealing with something like a machine, you want to determine its performance, like internal resistance, like the work function or the workforce or the leverage mechanism. You're supposed to give it like to determine the performance of a certain machine. So now after that, you know the machine you're using, you know what you want to determine within that machine. Remember, when you are dealing with objectives, your objectives are supposed to be smart with reference to whatever you are doing here. Your title and your objectives are kind of intermarrying as you go down. If you can check now, we've said the title is to doing this and this and this and this, for example. Now, when you go to the objective, now you're trying to give exactly what you're going to do within your experiment, what you want to achieve within your experiment. After that, after having the title and the objectives, now there's a time now you go to the theoretical background of the theory. And this one it gives you the relevant notes pertaining to the experiment which you are doing now. You are trying to explain the background of the experimental inquiry. And you are expected to read widely the subject of the experiment before coming to the laboratory. And you can remember very well, I told you such a thing. Read wide. Try to understand what you are coming to do in the laboratory. Just because when you come in the laboratory, you'll be national to do that experiment. And after that experiment, you will be in a position now to capture whatever you had read before. Try to intermarry it or intermix it with whatever you've done in the laboratory for you to be in a position now to understand the essence of whatever you've been doing here. And after having that, you'll be having complete knowledge of whatever you are asked to do. In this stage now of the experiment or report, you're supposed to not to rely on one reference. So a number of references should be consulted in this, either internet or books, or sometimes mostly since our research has advanced to a very higher level, mostly we have like almost everything has been done and it's online. Mostly we usually use other people's publications for we to be in a position to advance our research methods, our research ideas, our research knowledge. So all whatever you're supposed to be having, or whatever you require, you have it in books and in publications online. So now, whenever you are trying to get the background of your experiment, remember you are getting it from other sources. Be writing the references wherever you consulted, from wherever you consulted, be it in the books or in the internet. Because at long last, at the end of that report, you will be required to table all these references for whatever you've been doing. After theory, now that's where now we have the operators, and they should be listed in order of their usefulness and will help you. For them, at long last, they will help someone who will reach your book, maybe for reference or maybe for something else, will be in a position now to carry out the same experiment to verify your results using the same, whatever you've been using, like the apparatus. After the apparatus, that's where now if you're having circuit diagrams, if you have setups, that's where now we usually try to draw the diagram or the detailed experimental diagram which you are implementing to test is supposed to be written or drawn in this section. Sometimes we may find that the diagram which is on the manual is truly complicated beyond your and drawing mechanisms. What are we supposed to do? Some of us are not technical drawing tests. So what are we supposed to do? There is that freedom of you to manipulate that drawing for you to be in a position to get the exact touch from your hands and something which can be also understandable by the one who is going to use that experiment or report for his or her applications. After drawing this, remember after drawing either the circuit diagram or the diagram, The person who is going to mark this one maybe is not truly acquainted with the paths. So it's a must for you to label each and every part of that diagram for easy recognition, easy understanding. Are you together? Now, after that, we're supposed to be having the procedure now. This is another part which is truly, sometimes most of the students usually don't understand this part. And this part should be given in the past tense, the third person, often preferred in numbered steps rather than narrative paragraphs. What does this mean now? What is this third person? Why is it in past tense? Let's try to give it in another language, in another simple language. The procedure is given first in reported speech. When you are talking about that person, is someone we don't know. So someone we've never ever met, someone you don't know the name. So it means that this procedure will be given in a way that it was done by someone we don't know, either maybe someone or something. So it was done. That is in past tense, third person. After having this procedure, in the procedure, that's where now you have a step-by-step or chronological steps of whatever you've been undertaking within that experiment for you to be in a position to get the results. Now, after having the procedure, that's the time you're having the results. And this is the data, or the data you record during the experiment. This data, remember when you did it, when you did the experiment, you got that data from the lab. That data was recorded in a paper or somewhere where it was at long last signed by your instructor. The same data which was signed by your instructor is the same data which you will transfer to the section of the report. And after transferring this data to the section of the report, remember this signed data is an evidence that you were in the lab. So you are supposed to attach it at the back of your report book before you submit it for marking. This data which was recorded in the laboratory should be transferred 100% correctly the way it was done in the lab to your report. Any alteration will lead to punishment, maybe deduction of some marks, or it may lead to cancellation of the whole report because of those malpractices. Now, having the data which has been tabled in its place, we have now the analysis. What are we trying to analyze here now? We have the data, the raw data which we got from the laboratory. It's the time now for we to analyze this data according to the objectives and the title of our experiment. And should there be need of calculation and presentation of the results, it will be done using equations, graphs, discussions, and even error analysis. How are they going to be now? When we are talking of data analysis, we are trying to now, we have the raw data, the data which was obtained from the lab. This data, for it to be understandable, we are supposed to analyze it using the objective. Like if the objective was to determine the acceleration due to gravity using a simple pendulum. Now you're having the data which is including the time, the periodic time, and the length of that pendulum you're having. Now after that, remember, mostly when you are dealing with data, most of them in scientific language, we usually use equations, graphs, and after the graph, the equations, that is the numerical analysis, the graph, we usually call them the graphical analysis. Then after having numerical and graphical analysis wherever possible, we have the discussion. After the discussion is the one which leads to the error analysis of this data now. Upon having the graphs, sometimes not all reports will require a graph, but if need be for a graph, if is required, should be drawn on a graph paper and clearly labeled. What does it mean to draw it on a graph paper? Remember, when you are dealing with graphs, there's that marked squared paper or ruled paper, which we usually call the graph paper. the one which will aid us to draw a good graph according to the scale we choose for this graph. How are we going to label it? The title of the graph is a must and should be at the top. A captivating title of the graph according to the way you've been shown within there, or you'll be instructed within the manual. After the title of the graph, there's no way you can draw a graph without having a proper scale, which will guide you to draw that graph for it to fit within at least, and I say at least, 75% of that graph paper. So this scale, immediately after the graph, when you determine your scale, you're supposed to write it immediately below the graph, clearly indicating the scale of the x-axis and the scale of the y-axis. And remember, when you are drawing the scale, we usually use with the reference to 1 centimeter or 1 box of that graph paper. We don't usually use more than that. We usually use that reference like 1 centimeter represents blah, 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 according to whatever you are given there. But remember, since you are a scientist, you are a researcher, we know very well this. We usually, most of the time, we write one box, it's 1 centimeter. And it's not must for you to write 1 centimeter. When you say 1 represents this and this and this, each and every person understands this 1 represents 1 centimeter. After having that, now you draw your graph, indicating and marking the axis of the graph. Then after that, clearly draw all the points required for that graph. Do not use a blunt pen for you to draw a graph. We usually use a very sharp pencil for it to reduce the errors, for it to be on the safer side of the error. And this graph, again, and I will remind you again, it should accommodate at least 75% of that graph paper, meaning that the 25% which is remaining there is for writing the title and labeling the axis, and writing the scale. Now you have the graph. You've drawn your graph very well. You've indicated all what's required. Remember, you are going to use it for your further analysis. Now let's assume now you've used your equations and your graphs for your analysis, and at long last, like for example, you've gotten the acceleration due to gravity using the simple pendulum. Now that's the time now you go to the error analysis. What is this error now? The error analysis, remember, whatever you are dealing with as a theoretical value somewhere, most of them, they have their theoretical value, and that theoretical value, I am sure you got it when you were dealing with the theoretical background of this experiment. This theoretical value and the value you've gotten from the practical value now, they are compared within the error analysis part. And this is where now we analyze the errors by comparing the experimental results with the theoretical or the existing value of the quantities under investigation. Let's look for this example now, which is given here. If the experiment determined the acceleration due to gravity, g, using a simple pendulum or the pendulum bob, your results are 9.6 meters per second and the theoretical value is 9.8 meters per second. Then now for we to analyze this error, the error will be 9.8 minus 9.6, which will give you the 0.2 meters per second. Remember now, this will be your first part. And if you can remember very well, within your manual, you were given how to analyze errors. We have the absolute error, we have the fractional error. Then at long last, you are supposed to be having the percentage error, since within error analysis, at long last, we are supposed to compare each and everything using the percentage error. The error will be 0.2 meters per second. So that one is giving you the absolute error maybe. And you can now calculate the percentage error from this data. There are other error analysis techniques you can also adopt from the mathematical physics or even in the guide which you are given to you using the manual. Now, after having the error analysis, you are set now to make the verdict of whatever you've done in the conclusion. And within this part is where now we usually report what you have obtained from your analysis in section 9 and in line with your objectives and the error in your results. And for example, let's say now you had your title, you had your objectives, You had some information from the theoretical background, which you deduced, like within the theoretical background, that we usually get all the expressions we are going to use within our experiment. Now, after that, you're having the results. After having the results, now you analyze the results according to the expressions you're having, the graphical work. Now, after that, you've done your error analysis because you had the theoretical value and you have the practical value now. So now after analyzing that, you have the percentage error. In conclusion, this is where now you relate all whatever you've been having from the title, the objective, the theory, and the analysis. You are trying now to relate whatever you've been having above there to make it simpler, to make it cognitive, and to report it in simple words after relations. Now, let's say, for example, you had an experiment, or let's continue with the experiment. We are having the determination of gravity using a simple pendulum bob. Here, your objective was to verify the acceleration due to gravity using a pendulum. Then in your conclusion now, you are supposed to report this. The acceleration due to gravity using a simple pendulum is 9.6 meters per second, with an error of 0.2 meters per second, or 2.04%. Right together. After that, you just give a brief description of your finding and accuracy. After giving this now brief explanation or the discussion of your findings, that's the time now to ask yourself, now, I had this experiment. I had my objective of this experiment. I was led through the theoretical background by the publications and other sources. I got my results from the lab. I analyzed my results. I have compared my results with the existing or the theoretical value within the error analysis. Now, I've told the audience that this is what I got, and this is what existed before, and the difference was this percentage. Now, after discussing that and giving the reasons as to why this happened, I didn't get it with a difference of 0%. I had some errors and I had other issues. That's why we are talking about just give a brief description of what your findings and accuracy. Now, since I didn't get it 100%, and someone may use my tactics or may use my report to verify whatever I've done. If I didn't get it 0% difference, now, what caused this error? I've reported it within my findings and accuracy. Now, what do I want to be done within the lab? What do I want to be added within the lab session? What can I suggest for the lab to implement for if I will go back to the lab to try the same experiment, that I can get something which is almost equal, both the theoretical and the practical. That's the time now we go to the recommendation part, where you state briefly what you suggest that should be added to the lab session. What do you want the instructor to do in order to improve the experimental finding and minimize errors? What apparatus do you want to be changed so that the accuracy is enhanced? And before we go, within the recommendation, that's where many people usually mess up with the whole system. You are here, you are a student. You are trying to recommend something which you are in a position to do, and you are recommending it for someone to do it. Remember, if you were to clean the apparatus by yourself, and here within the recommendation, you are saying that the apparatus were supposed to be cleaned, you are trying to turn to be something else, and this one is a very great sin. It's a very great offense within the research methods. Whatever you were in a position to do by yourself, please don't try to recommend it to be done for the lab for you to get proper results. Whatever you were in a position to do for you to minimize these errors, please do it when you are doing your experiment, and don't try to recommend it to be done by someone. Are you together? Now, having the recommendation, I've suggested whatever should be added in that laboratory for it to, or the accuracy to be enhanced. I can say I'm almost through with my experimental report. But now, since I'm through with whatever I was supposed to do, now I refer back to the theoretical background. If I can remember very well, within the theoretical background, we said that whatever you've been using to obtain the data which you wrote in the theoretical background, you are getting it from the internet, from publications, from books. Now you were listing all the references. So at the end of that experiment, that's where now we usually list the references we've been using. And these are the source information you have been applying within your lab session and report writing. Now, remember, as a researcher, you are not supposed to rely on a single source of information. Multiple sources of information are truly good for someone to be called a researcher. For me, to do a good research, I must rely on more than 3 references. And all the references I relied on, I must, at long last, list them at the end of that experimental report at the references place. How am I going to do this? I'm going to give you a small takeaway for you to go and research on how to do your referencing using the APA style of referencing. I'm sure you'll be in a position to get all whatever is required for you to do referencing using the APA style of referencing. That is the American Psychological Association style of referencing. Now, up to that point, I think that can help you in a bit. But now, let's try to make it a bit simpler now for you to understand what you're supposed to be doing so that we can be in a position to write at least a better report which can give you something tangible, let me say so. Now let's try to check this example of a report here. This is a report I did by myself, let me say so, with a title, Measurement of Acceleration Due to Gravity. So now, this report, remember, before we wrote the title, Measurement of Acceleration Due to Gravity. There is another date high above the title, which I used, a date which is indicating the time I did that, the day and the time I did that experiment. Then immediately after the title, there's another date. This is the date which I wrote this report. I think you understand me. This is the date I wrote that report. Before the title, there's a date. Mostly we usually write it at the rightmost end of that page. The date of the experiment. Then after the title, we have the date of writing that report. After the date of the report, now I have the aims or the objectives of the experiment. The aim of the objective of this experiment I did was to measure the acceleration due to gravity, g, by a simple pendulum. We said that the objective is always SMART. 2, measure the acceleration due to gravity by a simple pendulum. Ask yourself, how smart is this one now? It's upon you to understand that because communication skills we still are doing this. Now to the theory, if you can check very well now, the theory is very concise and express, giving all the information I am using within my experiment. The information I require, the total information I require for my experiment, blah, blah, blah. If you can check the information you are having within the theory, then after the theory, you can remember very well, we have the procedure, and we said that the procedure is supposed to be given in past tense, reported speech in the third person. Now, if you can check, the black ones I'm having here is what I was given within the manual. So the first one, and here I've used a different mechanism. I've put my procedure in before the diagram. It's allowed to. So now let's take the procedure number one. We are told attach a piece of thread about 1.6 meters to the pendulum bob. That's what I was given within the manual. For me now, at long last, I'm not supposed to write it express like that. We say that you are supposed to report it in third person past tense. So now, here is how to report it. Do not include that part within the report. So the red part is an example of whatever I'm supposed to write within the report. That point number one, a long piece of thread about 1.6 meters was attached to the pendulum bob. Who attached it? I don't know. That's what I meant when I was talking about the past tense, that person, a reported speech. If we go to point number two, this is what was given within the manual, the highlighted one now, the one which was given within the manual. So after getting that, this is how to report it using the red part. The top of the thread was held between the clamps of the retort stand as shown in the figure below. So now, that's the point now. I've included the figure I'm having here. You can see the figure I'm having there now. Then after that, having the figure, it's well labeled using the retort stand, the pendulum bob, and all whatever information you're supposed to be getting is here. Then set the bob oscillating through a small ankle. That's an example of whatever you've been given within the manual in the instruction we are given. But at long last, I'm not going to give that instruction the way it is. I'm going to take it the way it's supposed to be within the report. The blue part now is the one, an example of what I'm supposed to report within my report. That the bob was set to oscillate through a small ankle and the time for 20 complete oscillation was found. And it goes like that until you go to the end of that experiment, that procedure. Now, having that procedure the way it is and using let's give it a bit of time for you to be in a position to understand it. So the procedure page one, it was like that. We go to procedure page two, you can get it like that. Procedure page three, you can get it like that. Then after that, now after having the procedure, now that's the time for data analysis. The data I got there, the data which was assigned there, this is an example of the data I got. Now you can check it very well. This is an example of that data. If I can remember very well, I used an 100 grammars, 1 meter roller stick. Now, the period of 20 oscillation was measured over 5 trials, and the corresponding value of G for each of these trials was calculated. And the following data for each trial and corresponding value of the G are shown in the table below. If you can check, we have the trial numbers, we have the measured period, and we have the value of G in meters per second squared. Remember your data at long as you didn't get it like this. I've tried to minimize the time and space for writing this one. Remember you had all the other data which you got to in the lab. This is the manipulation part of it. So you're supposed to include it, whatever you got in the lab here. After that, we have the data. Now we go to the graphical analysis. I'm having my title there, and I'm having my scale. I'm sure your scale is totally different from this one because this one is directly emanated from the computer. But for you, you know how to give the scale. If you can check all my axes are truly labeled, including all whatever I'm having. Then after that is graphical analysis I'm having now. Within the calculation, this is where you do all your calculation regarding the subject matter. Having the graphical analysis here, like the gradient, if you're supposed to be using the gradient somewhere for you to at long last get the acceleration due to gravity. Now after that, you're having the error analysis. Like you can remember whatever you've been using there. Now the error analysis will go like absolute error. We have the fraction error, we have the percentage error, and it's good to follow all the procedures you are given within the first experiment, which is M1 measurement, that is precision measurements within a manual. It will give you a clear indication of whatever you're supposed to be using as your error analysis. Now, after that, we go to some notes concerning whatever we've done before even we go to discussion and conclusion. If you can remember very well, our final measure, whatever you're having here, you can try to summarize it using some sentences. Like, for example, you are given here, like our final measured value of G is this plus this error. This was calculated using the means of whatever. If you can check the way it is with that standard deviation. Now you have the relative uncertainty of the relative error of the value you got using the percentage, and the relative difference with the accepted value is this, which is well above the relative uncertainty. You understand? But if you don't understand this part very fine, for now, don't bother with it. We'll come back to it. Now you go to discussion and conclusion. So in this experiment, the measured value G was found to be this and this and this. This has a relative difference of this margin with the accepted value, and our measured value is not consistent with the accepted value. All of the measured values were systematically lower than expected. It was found that the measurement of G had a much larger uncertainty as determined from the spread in the values that were obtained. Why? That's the time now we are having the sources of error. It was suspected that by using 20 oscillations, the pendulum slowed down due to friction, and this resulted in a deviation from simple harmonic motion. This is consistent with the fact that our measured periods are systematically higher. It was not possible to accurately measure the angle from which the pendulum was released, as there was no use of a protractor. But this is just an example of the source of error, which is not up to this experiment. According to me, please do not write something like this one, because I will ask you how you got this one and how it's affecting the experiment you are doing. So be aware of when you are trying to give a source of error, be in a position to understand and explain as to why it's affecting your results. So please don't write something which you know you can't explain how it's affecting the results. After that, now you have the recommendations. If I have these sources of errors, what is supposed to be done by the lab for me to be in action at long last to get the required information concerning this experiment, the required value concerning this experiment? If this experiment could be done measuring 10 oscillations of the pendulum rather than 20 oscillations, could provide a more precise value of G. Additionally, a protractor could be tapped to the top of the pendulum stand with a ruler taped to the protractor. This way, the pendulum could be dropped from a near perfect 90 degrees rather than a rough estimate. This one is going in line with my sources of errors. But for you, you are using a free oscillating pendulum, which didn't regard or was not using the ankle. So here, that was a free experiment. So please, whenever you are trying to give the source of error and the recommendation, please try to understand what you are talking about and let it be something tangible and something practical. Do not write something you don't understand. Now, after that, after recommendation, that's the time we go to the references. If you can check very well, these references which are recorded here are following the APA style of referencing. As I had given you a takeaway for you to go and study about the APA style of referencing. Please try to understand the APA style of referencing. If you can check very well, I've not used less than 3 referencing mechanisms. And remember now, let's talk about it very well. If you want to use that manual as a reference, learn how you can use that manual as a reference. And mostly we usually discourage students using that experiment manual as a reference. For most of the people, you can't be in a position to get that manual after this, just because this one is just within Chuka University. What if someone now accesses your information or accesses your reports and wants to use that manual as a reference? Where will he or she get it from? Let's try to use other locally available references for our work. Now, And if you can remember very well, I can say now, having that small part of it, you can be in a position now. You can be in a position now to write a better report, if I can say. I'm talking of a better report. I know you have information concerning whatever you're supposed to be writing, but having this one can try to elaborate for someone how you can get, how you can try to write a better report, which can earn you something out of it. If you remember very well, if you don't understand any part of it, I am here. You can reach me using that number, or you can get the number, my number from your class rep. They can give you my number or the other instructor's number for you to be in a position to utilize the remaining time before Tuesday next week, because I'll be collecting those reports on Tuesday next week. So be you, be serious, try to understand what you are doing, and write a good report. All the best, and have a nice time as you write all the reports. And maybe after that, you can say Merry Christmas and have a festive season. Good day to you all.